It's more like a discussion. So you guys should feel free to interrupt with any questions or thoughts as we explore together. Okay. So our first topic is what are algorithms? So in simple terms, it is problem solving instructions for computers. Now, let me say it like this. Like imagine you are in a pizza shop and your goal is to organize the delivery of pizzas to nearby neighborhoods efficiently. So now how do you decide the order of deliveries? This is where the algorithms comes into play. Like think of the shop's delivery process as an algorithm. So the delivery person doesn't randomly choose routes, right? So they follow a sequence. Okay, just give me a second now. Okay. They follow a sequence. So first delivering pizzas to nearby locations and then gradually moving forward. So in this way, they optimize time and fuel. So ensuring hot, fresh pizzas reach every customer. So similarly, in algorithms, we organize tasks like delivering pizzas by following a set of steps to achieve efficiency. So, and have you ever wondered like why we need algorithms? Okay, let me link this with the previous example. So you have got limited time, like that delivery person with only limited hours for pizza runs, but an endless list of deliveries to make. So it sounds like a little bit tough, right? So if we come into programming and algorithms in computers, resources are limited, but the problems are unlimited. So we can say that algorithms are superheroes for computers, like they tackle big tasks. So as some examples are shown here, and if I go one by one them, finding the best website. So you all have Google something, right? And most of the time you have found exactly what you needed at the topmost link, right? So that's thanks to Google's page ranking algorithm. So it's like having the best librarian who knows exactly which books are the most popular and puts them right on the top of the stack. So just like well-organized library, page ranking algorithm sorts through web pages and serves up the most relevant ones at the top. So like that, making our search experience so much smoother. So, and the next one is then and also I'm pretty sure that you all have used Google Maps, right? So at least once. So what it does is guiding us through traffic with the fastest route to the destination. So if we just simply tell it like that, it seems like a pretty small thing, ne? So just like getting the data from a server and giving the route to the customer. But if someone can think like really think about that under the hood, so there are like lots of algorithms running, like maybe we will not even imagine the number. And another example for algorithms is ad suggestions in social media. So ever notice that spot on ads on Facebook or Instagram that seem like read your mind? So that's how algorithms doing their magic. So they are like your personal shopper suggesting you stuff that might actually want. So it's like your favorite restaurant, like the one you are visiting mostly knows your usual order. Just suggestions get what you are into, and making your online experience more about things you love and less about random stuff you'll have to scroll past. So, and then now let's dive into something somewhat like technical stuff. So expressing algorithms. So an algorithm is a step-by-step set of instructions designed to solve a specific problem. So, and as it's mentioned here, an algorithm is a sequence of finite steps or instructions to solve a problem. So algorithms can be expressed in various forms. The most popular two common methods are pseudocodes and flowcharts. So pseudocode uses a mixture of natural language and basic programming structure to outline the logic. So like in here, do you know what is a factorial? Can I see some raise of hands to get some idea? Uh-huh. Only three. Ah, okay, all right. okay, I think you all are coming from like mathematical level. You did maths in A levels, right? So that if you did maths in A levels, then you most probably know it, but you just don't know the English term of that. So it's in Sinhala, it's Kramaropitaya. So like, anyway, I'll just explain it. So think if we need to find the factorial of n, then the factorial is the product of all positive integers less than or equal to n. So, and as an example, let's say if n is 5, so means we need to find the factorial of 5. So what do we have to do? We have to multiply the 5 with all the numbers before 5. It means 5 into 4 into 3 into 2 into 1. Okay, if I calculate the answer is 5 into 4 is 20, then 20 into 3 is 60, 60 into 2 is 120, 120 into 1 is 120. Same. Okay, so now let's see how we can express this factorial algorithm from a pseudocode. So as you can see in the slide, it shows the factorial function. This is the factorial function, and it takes the input as n. We call the input as as a parameter to the function. So in this, and this is a recursive function. Okay, so I think you may heard about what is a recursive function, or you may not. So I'll just explain. So recursive function is a function that calls itself inside the same function. There are many forms of recursive functions. This is the direct recursive function. I'm not gonna go more into more details into that. So I'm just explaining in the like from the topmost shell. So, and then here, this is the base case. Okay. So every recursive function has a base case. And here in this example, this base case checks if n is equals to 0. And if n is equal to 0, it returns 1. So, and then else, in else part, this is the recurring parameter or recursive case, and it returns n into factorial n minus 1. So, and this recursion effectively like reduces the problem to smaller sub problems until it hits the base case. So, and you can try to apply that factorial of 5 into this pseudocode and try it for yourself, maybe after this session. So anyway, maybe you all know like this already know this stuff, but so now in the other hand, flowcharts use graphical symbols to represent different steps that decision points in the algorithm, like in the diagram shown. So in this flowchart specifically, so shows the sum of the numbers from 1 to 50. So obviously I don't need to explain it to you guys. Everyone can see it and understand. So you are doing computer science, and whether in pseudocode or flowchart, the goal remains the same: a precise, well-defined sequence of actions. And also we can say that algorithm serves as the backbone of problem solving in computer science. Like it provides the roadmap for tackling complex tasks efficiently and systematically. And then, so here what we are going to discuss is like what there are, like what is the characteristics of algorithm design. So algorithms need to be correct. So this means that algorithms must provide the right output for all possible inputs. Think about the vending machine. You all know what is a vending machine, right? So what we do is we put in coins, and then we make a selection, and then we expect the right item will come out, and then the selected item will obviously come out. So similarly, algorithms need to give the correct result regardless of the scenario. And then algorithms need to be ambiguous. This means I think you all know what is the meaning of ambiguous, right? Its meaning simply clear. I can say it like that, like අපැහැදිලි නැති, පැහැදිලි. So algorithms need to be unambiguous, and that means like algorithms should be crystal clear, like leaving no room for confusion or multiple interpretations. So as an example, consider a receipt for a baking cake that you are telling your friend about steps to baking cake. First mix ingredients A and B, and then C and D, and then mix them together and then bake for 30 minutes. It's crystal clear and leaves no room for ambiguity. So like that, algorithms must be pretty clear. And then algorithms aim to be fast and use memory wisely, focusing on how much time and space they need. So think of it like this. Think like it's like that deliver driver trying to find the fastest route to deliver packages. So they aim to reach each destination quickly without taking unnecessary delays. So just like algorithms aim to solve problems swiftly. Additionally, the driver tries not to overload the truck with unnecessary items. So it means like the driver වැඩක් නෑනේ ගොඩක් එයාට ගෙනියන්න ඕනේ නැති මේ එක items දාගෙන ගිහිල්ලා ඒ වගේ තමයි algorithms වල ඔයාලා ඒ කියන්නේ ඔයාලට ඕනේ නැති like හිතන්න ඕනේ නිකම් variables define කරනවා කියලා ඒ වගේ variables define කරලා කිසිම වැඩක් නැහැ. ඔයාලා use වෙන්නේ නැති variables ඒ වගේ list ඒ වගේ define කරලා දන්නේ නැහැ. ඔයාලා use kind like VS code වගේ use කරනවා නම් ඒකේ කියනවා ඔයා මේ variable එක define කරා ඒ මේ variable එක කොහෙවත් use කරලා නැහැ කියලා නේ පොඩි යටින් error message එකක් වගේක් එනවා. අනිත් ID ඉස්සලත් එනවා. මම වැඩියෙන් use කරලා නැහැ. Okay. So like that, algorithms use memory wisely by not using more space than needed to complete task efficiently. And then an algorithm can has two types of answers. One is precise answer, and then the second one is approximate answer. So if we talk about what is precise answer is, precise answers are accurate and exact solutions to a problem. Like they provide the exact output required. Imagine calculating like 2 plus 2, the precise answer is 4. So leaving no doubt about the outcome. As another examples, I can say like computing the factorial of a number, so finding the shortest path between 2 points in a graph, or sorting a list of numbers. So all of these like aim to precise and accurate outcomes. So if we talk about what is approximate answer is, so the definition of approximate answers is they provide a close estimation or an acceptable solution when achieving an exact solution is challenging or time consuming. So instead of an exact value, it offers a near accurate result within an acceptable range of error. So if you can't solve the problem by trying all possibilities, what if we solve a small version first? Common ways of solving algorithm is to break it down into subproblems. So think it like this. Imagine your room is so messy now. So you can't arrange it everything at once, like just like Thanos did from just one snap to remove half of the people in the universe. We can't do that, right? So what do? We break it down. So tackle one area at a time. Maybe start with the desk and then to the closet and then to the bed. Likewise, in problem solving, if the main task seems so overwhelming and complex, so what we do is break it into smaller, more manageable parts, like solving each smaller mess separately, like what we are doing in arranging our messing room. So it makes the overall problem easier to handle. So like this approach, dividing problems into sub-problems, makes algorithms complex tasks more achievable, just like cleaning the room bit by bit until it's all tidy. Tidy means පිළිවෙල. Okay, so sub-problems. Okay, now let's look into how these sub-problems work. When it comes to dividing problems into sub-problems, algorithms can be categorized into two. Okay, based on the behavior of sub-problems. The two categories are non-overlapping branching and overlapping branching. Okay, now let's see what is non-overlapping branching. So in algorithms with non-overlapping subproblems, each subproblem is solved independently, and the solution to subproblems do not influence on one another. The approach is typically straightforward. The solutions are computed only once for each subproblem. Like this kind of division is common in dynamic programming algorithms. So you now may think that what is dynamic programming? Dynamic programming will be discussed in the upcoming slides. Okay. So for an example, we can take the merge sort. It's a sorting algorithm that divides the array into halves, then sorts each half separately and merge them back together. So anyway, it will be discussed in the upcoming section, so I'm not going to go deep into that. And the next category is overlapping and branching. So algorithms with overlapping and branching subproblems involve solving subproblems that share common solutions. In this case, there was no common solutions, but in here there are some common solutions. So these common solutions are calculated and reused across different branches of the problem. So, and this method is often found in like recursive algorithms, where a problem is divided into subproblems, and these subproblems in turn may further branch into more subproblems. As like in this picture, when it goes from stage 1 to stage 2, the SOC CO 0.7 divides into like 3 different nodes, and then when it goes from stage 2 to stage 3, those 3 divides again to more. Likewise, this goes on and on. And as an example of an algorithm with overlapping subproblem is like a classic dynamic problem of finding the shortest path in a graph using algorithms like Bellman-Ford. For now, just remember there are something like that, but in this session we won't talk about the Bellman-Ford. But if you are really interested, you can go and search on the internet and look for it after the session. So to sum it up, understanding how smaller parts of a problem relate or work separately has a big impact on how well algorithms function. And this insight helps algorithm designers choose the most effective way to tackle complex tasks. So, okay, algorithm types. Now we'll talk about what are algorithm types, and in these slides, I'll just talk about those two. We are gonna anyway discuss those two separately in the coming slides. So greedy algorithms. First one is greedy algorithms, and then second one is the divide and conquer algorithm. So greedy algorithms make decisions based on the best immediate choice at each step, so without considering the overall effect. And then the divide and conquer algorithms, they break problems into smaller tasks, more manageable subproblems to solve independently. And then now let's dive into greedy algorithms. So as I already said, the name speaks for itself. Like greedy algorithms are a class of algorithms that make locally optimal choices at each stage with the hope of finding the global optimal solution. And greedy algorithms provide a powerful approach to problem solving, with application ranging from like scheduling tasks to complex things like network optimization and beyond. So I think what is a greedy paradigm? So I think you know what is a paradigm, right? Paradigm means a pattern or a model, we can say it like that. So, and algorithmic paradigm that follows the problem solving approach of making the local optimum solution, local optimum choice at each stage with the hope of finding a global optimum. So it's about making the best decision, like making the best decision at the moment, anticipating that these local optimal choices will eventually guide you to the best overall solution. So just as in life, sometimes choosing the best option available at the each moment in life helps in reaching the ultimate goal. So now you may think, what is the picture in the left? So now think it as a picture of Sri Lankan buffet. So it's for understanding the greedy approach. So in Sri Lankan buffet scenario, using the greedy approach to arrange the food would be like strategically placing the most appealing and popular dishes at the start of the buffet line. Like picture it as setting up the line with mouth-watering dishes like kottu or biryani or hoppers at first. The idea is that people starting from the beginning. So no one will start from the end of the buffet, right? So then they are more likely to pick these tasty options early on, enjoying the best food before they get full. So this illustrates like how a greedy approach works by making immediate decisions that seems best at the time, aiming for an overall favorable outcome. And in the second one, like in this animation, it shows a drawback of the greedy algorithm. Okay, so here the goal is to find the largest sum in this graph. And so we are starting from the 7, the topmost node. And then initially we see two sides like node 3 and then node 12. So from the greedy approach, we choose node 12 because it is the best optimum solution at the time. And then we go for node 12, and now we are here. And then we can see that node 5 and node 6. So and then we will select node 6. So 7, 12, and 6 was selected, and then from the greedy approach, and then sum will be 25. But as you can see, the actual largest sum is not that, right? So it's 7, 3, and 99 is the largest sum, which will result in 109. So it's like there are some drawbacks in the greedy approach as well. Okay, so let's move on. When to use greedy approach? So the greedy approach is most appropriate when problem has the following characteristics. Like there are two characteristics, and first one is greedy choice property, and then the second one is optimal substructure property. So what is a greedy choice property? So as I have been telling like 100 times now, it simply state that at each step selecting the locally optimal solution leads to a like global optimal solution. And then the optimal substructure property is uh, it's that an optimal solution to the larger problem can be constructed from optimal solutions of its small subproblems. So as an example, we can take the Fibonacci series. So I hope that you all know about the Fibonacci series, or I'll just explain what it is. So Fibonacci series is a sequence of numbers where each number is the sum of the two preceding ones. Typically, it starts with 0 and 1. So it goes like the first two numbers are 0 and 1, and then the next number is the sum of the first two numbers, like which equals 0 plus 1 equals 1. And then the next number is the sum of the previous two numbers, which is this 2 has been formed like 1 plus 1. 1 plus 1 is 2. And then the next number is 3 plus 2, 1 plus 2 is 3. And the next is 2 plus 3 is 5. Like that, the list goes on. So in that, computing the nth Fibonacci number involves solving smaller subproblems for Fibonacci numbers smaller than n. So the optimal substructure property ensures that the solution to the nth Fibonacci number relies on optimal solutions to Fibonacci numbers of n minus 1 and n minus 2. Okay, that's what optimal substructure property is. And in summary, the greedy approach is suitable for problems where local optimal solutions lead to globally optimal solutions, and problems can be broken into subproblems with optimal substructure. Okay, now let's move into a problem. And try to find the solution in greedy approach. I think I will give some time for you to come to a solution for this. So, okay, the problem is fractional knapsack problem. So knapsack means like a bag, like in Sinhala, kadamallakko again, ඒ වගේ එකක්. And this is fractional knapsack problem. So there is another type of problem called 0-1 knapsack problem. So the difference is in this fractional knapsack problem, we can put fractions of items into the knapsack. But in the 0-1 problem, we can't put fractions to the knapsack. Either we have to put the whole item or not. So like think like in this problem, this ABC, think it as apple, orange, and pear. So in the 0-1 problem, think them as like a fridge, a TV, and a washing machine. So we can't like take a fraction of them. So yeah, like that. So if you move on to this question, so imagine you have a knapsack with a limited weight capacity, and there's this set of items, each with its value and the weight. So like as shown in the slides, the knapsack has the capacity of 50 units, and the each A, B, and C item has its own weight and the volume as shown. So here weight is shown as WT. And the goal is to select items to include in the knapsack in such a way that their total value is maximized without exceeding the knapsack's weight limit. And as I already told, this is a fractional problem, so you can put fractions of the item to the knapsack as well. Okay, so like now I'm going to give you like 5 minutes to think for a solution. So if anyone doesn't understand the problem, can ask me, I'll explain it again, like in sing hello, whatever you can ask. Or else I'm going to start the timer now. Wait, so you can think for a solution. I'm just doing this to like make you engage with the session. Okay, the time starts now. Think for a solution. Think for a greedy solution. Uh, okay. I think 4 is more than enough. I hope you are working on it, like thinking for a solution. Okay, now the time is up. So have any of you found the solution to this? I think there are some answers in the chat, but can any one of you like unmute your mic and tell me how did you approach that answers? Like language doesn't matter, you can tell it in English or Sinhala, whatever. ඕන එකකින් කියන්න කේස් යන්නේ නැහැ. කවුරුත් කතා නැද්ද? It's all right. Someone has put some message in the chat saying that choosing the items based on the value per volume from highest to lowest. Okay, that's the correct approach. As you can see here, so this is the solution. The solutions has 4 steps. So which are, the first one is calculating the ratio value to weight for each item. And then the second one is sort the items based on this ratio. And then the third one is take the item with the highest ratio and add the maximum weight possible. And then the fourth one is move on to the next highest item and repeat the process. Okay, now let's see how it applied. Like here, the first step was to calculate the ratio for each item. So which is shown here, like for the item, like by calculating the value per weight ratio, what we are getting is the value per unit weight, right? So if we calculate it, as you can see here, for A, it's 60 divided by 10, and the answer is 6. And then for B, it's 100 divided by 20, which is 5. And then for C, it's 4. So, and then the second step was to sort items based on this ratio. So it's already been sorted like in the ABC, order. So, and then the next step is take the each item with the highest ratio and add the maximum weight possible of that item to the knapsack. So start selecting the item from the first of the sorted list. So begin with the item having the highest value to weight ratio. So as here, it's A with 6, and the weight of it is 10 units, right? So we put the whole 10 units of weight to the knapsack. Okay. Okay, let me. All right. So now the next step is, so there's capacity in the next step is 50, and then the weight of the item A is 10. So we can put the whole 10 units of the A to knapsack. So the next process is to repeat the process. And now the B has the highest ratio and it's 5. The next is B and it has the highest ratio and it's 5. And like there are 40 units of capacity remaining in the knapsack, and we can put all the 20 units of weight in B to that. Okay, and now the remaining weight of the knapsack is 20 units. Now the whole A and B is put into that, put into the knapsack, and then the remaining weight is 20 units. And so in the item C, there are 30 units of the weight, but the remaining weight of the knapsack is 20. So we can't put the whole C items to the knapsack. So we are putting only 20. So like 20 units of the C items to the knapsack. So because it is the fractional problems, we can put fractions of the items to the knapsack. So like that, now the knapsack is full and the value is maximized. So I think I'm not sure about the correct answer. I think it's like, okay, let's calculate it. First we put the 60 and then 100, and then how we calculate what we are putting in here. So it's like 20 divided by 30. We are putting 20 out of 30 and into 120. So it is 80. It is 80, and then answer is 100, 160, and then 240. The correct answer is 240. Okay. Now let's move into another question. So this problem name is job sequencing, and the question is, given an array of jobs where every job has a deadline and associated profit to them, and if the job is finished before the deadline, it is also given that, like, if you have done the job before the deadline, that then only you will get the profit, right? So it is also given that the every job takes a single unit of time. So, and the question is how to maximize total profit if only one job can be scheduled at one time. So මේක නම් පොඩ සිංහලෙන් මම කියන්න නිකන් එක්ස්ප්ලেইন කරන්නම්. මේකේ තියෙන්නේ like මෙහෙම jobs පහක් කර කීයක් හරි මෙහෙම තියනවා job set එක. ඊට පස්සේ ඒකට associated deadline එකක් තියෙනවා. මේකෙන් කියන්නේ මේකට යන වෙලාව නෙමෙයි, හැම job එකකටම යන්නේ එකම වෙලාව එක unit එකයි. ඒ කියන්නේ එක තප්පරයයි කියලා දන්නවා. ඒ කියන්නේ එක තප්පරයි ඒ job A කියන එක කරන්න යන්නේ එක තප්පරයයි. අද job B කියන එක කරන්න යන්නේ එක තප්පරයයි. ඒ වගේ හැම එකකටම එක තප්පරයයි යන්නේ. deadline එක කියන්නේ තප්පර දෙකක් ගියාට පස්සේ මේ job එක කරන්න බෑ. තප්පර දෙකෙන් පස්සේ මේ ජොබ් එක කරන්න බෑ. තප්පර දෙකට කලින් ඕනේ තප්පරයක මේ ජොබ් එක කරලා ඉවර කරන්න පුළුවන්. and ඒක profit එක 100යි. Okay, so ඕකටත් තියෙන අර වගේම approach එක. I'm not gonna give you time to do that. So I think by now everyone got the idea about what is the question is. So, and here's the solution for that. So, and I'm not gonna explain the solution now, so you guys can go through it because of the time constraint. So, and I also attached the YouTube video link for the same question, so you can go through that too once you get these slides, or simply you can go to YouTube and find by this problem name. Okay, now practice makes you more confident, right? The more you practice, the more you will be confident about yourself. So, and your end goal is to make yourself ready for competitive programming. And for that, you need to familiarize yourself with algorithms and critical thinking. So here are some links to HackerRank algorithms questions and Geeks for Geeks greedy algorithm section. So you can go to them and then refer to them again and gain some like vast idea about these sections when you have free time. Okay, now let's talk about what are the pros and cons in these greedy algorithms. So the pros are it's simple and easy method, and then can obtain partial results in competitions, and then less time complexity. So greedy algorithms are, okay, is anyone talking? Okay. Greedy algorithms are straightforward and easy to implement. So, and like in time bounding scenarios, like in competitive programming, greedy algorithms often provide quick and acceptable solutions. So maybe sometimes, like, even though you can't find the solution which passes the old test cases, but you can get past some by greedy methods. And also, like, they often have lower time complexity compared to some other methods, and they tend to be efficient in terms of computational time. So if we talk about cons, so every problem can't be solved using greedy approach, and sometimes it's hard to find the correct approach. So greedy strategies are not universally effective for all problems. Like some problems require considering future steps, not just immediate choices. So where greedy algorithms might fail. So identifying the correct greedy strategy for problems might be challenging sometimes. And yeah, with that, I think the greedy algorithm types are now finished. Now let's move on to the other algorithm part, which is algorithm type 2, and it is divide and conquer. So in divide and conquer is an algorithm. Divide and conquer is an algorithm paradigm that involves breaking a problem into smaller sub-problems, like, and then solving them independently and combining their solutions to solve the original problem. So this divide and conquer method is used when the problem can be divided into smaller problems, and solutions for those smaller problems leads to the solution of the original problem. So it has like mainly three parts involved, which is divide, conquer, and combine. So divide is divide the problem into smaller subproblems, and conquer is solve those subproblems recursively until it comes to the base case. So I hope you remember what I said earlier in the session about the pseudocode, like finding the factorial of a number. We use this conquer strategy there. And then finally we have combine. So what it means is like after solving those subproblems, we have to combine the solutions of those subproblems to get the solution for the initial problem. So okay, so this approach like particularly powerful for problems that exist an optimal substructure. What is optimal substructures? I explained earlier. So meaning that the optimal solution to the overall problem can be constructed from optimal solutions to its sub-problems. So algorithms like merge sort, quick sort, then binary search have this divide and conquer strategy. And so we will look for some of them in the next slides. Okay, here, the merge sort. The merge sort is a classic sorting algorithm that directly implements the divide and conquer approach. So it like efficiently sorts an array or a list by recursively dividing it into smaller subarrays and sorting them independently. And then merging the sorted subarrays to produce the final sorted result. So, and we can see it like this. So remember those three methods are divide, conquer, and then combine. So divide part is the like as you can see here, we are dividing that initial array into two subarrays. So usually we do it by finding the middle point of the array and divide the array from there. So here there are 7 elements in the array, and then the middle element will be the fourth one. So we are dividing from there. And then the conquer step. In conquer steps, what happens is we are sorting those two sub arrays separately. As you can see here, the left array and the right array are now sorted. So how we do it, you will see in the next slides. And now the third step, combine. Now we are in the merge sort, we are calling that combining part, we call it merging. So now we are merging that sorted two subarrays by looking at the comparing each item with their indexes. So to make it more clear, in the next slide, I will give you the whole process to that. Okay. And now here it is. So as you can see here, in the first half of the slide, what we are doing is the dividing part. And in the next half of the slide, we are combining them again. So actually in the last three slides, we only like did for the second step, second line, and combined again these two steps. And then this middle part, sorry, and this middle part was not there. As in the previous slide, as like in the previous slides, we do not stop there. We divide them further as going further from this step. So until it reaches that stage, we cannot divide the array like anymore. Like as you can see here, we can't divide these numbers or elements anymore, right? So which means that there is only one element left in the array. And then what we do is we are comparing each item and then merge them back together. Like we are checking if the 27 is less than or greater than to the 37, and then we are looking like for each indexes and then merging them back together to make the sorted final array. So that's how the merge sort works. I hope you got an idea about how the merge sort works, and this is the pseudocode for the merge sort function. So as you can see here, this merge sort function accepts three parameters like A, P, and R. which is A is the array we are given, and P represents the index of the first element of the array, and then R represents the index of the last element of the array. So, and like this here, we are first checking if P is less than R, which means that we are checking if there's only one element in the array. So this is a recursive algorithm, and then we are calculating Q, which is the midpoint of the array. So we have to like calculate the midpoint of the array to make those two sub arrays. And then what we are doing is we are calling the merge sort function again with the current array. For the A, we are giving the input as the current array, and the first index is the same and the same as the original array, and then the last index is the mid index, which was calculated here. So here we are passing the divided first half of the array to the function here. And then in the next line, we are passing the divided next half of the array to the function. Like now, the first index is the Q plus 1, which is the next element after the middle element. And then the last index is the actual last element of the array. So like that, we do it over and over again until there's one element remaining in the array. And then what we are doing is now we are creating that tree like you saw in the previous slide. And finally, we are calling the merge function recursively. So I think you got a rough idea about the merge sort. So you guys better go and practice implementing the algorithm yourself. Like this is just the pseudocode. So, and you can implement this in any programming language that you are comfortable with. Okay, now let's move on. And this is another divide and conquer based sorting algorithm, which has the name quick sort. So here what we are doing is we use an element in the array as the pivot element. As you can see here, we have selected 27 as the pivot element, and then we are taking the element that is smaller than, like all elements that is smaller than the pivot element to the left side of the pivot element, and then the elements that are larger to the pivot element to the right side of the pivot element. So that's how we partition the arrays into two arrays in quicksort. And then what we do is we are sorting those two arrays, two like sub arrays separately, and then we will get the result. We will get the sorted array. Like in the previous case, as in merge sort, we don't have to check each item from sub arrays when merging, because here the numbers in the both sides of the pivot element do not get crashed. So no explicit merging is needed here. Okay, that's it about the quick sort. So, and here I mentioned some other algorithms that you can go and look at, and I also inserted links to them as hyperlinks. So you can click on these names and go to them. So when you get these slides, you can go through them and refer to them when you have free time. And obviously you will have to do it if you are going to face for competitive programming and you are thinking to like face them really well. So like the base of the competitive programming, what you are like the golden treasure of the competitive programming is knowing the like mastering the data structures and algorithms. And then so far, as the summary for what I did for now is we talked about greedy approach to an algorithm, and then divide and conquer approach to an algorithm. So greedy approach is the selecting the best option at each stage, aiming for a quick solution. And then the divide and conquer approach is the divide the problem into smaller sub problems and solving them iteratively and combining solutions. So yes, that's it from me from now onwards. So I'm handing over the session to Sunera to conduct forward. So he'll be doing about the dynamic programming part. And thank you guys for listening to me, and over to you, Sunera.
Okay, thank you. Yeah. Wait, I share the screen. Can you see the screen now?
Yes,
Yes,
sir,
sir,
yes.
can see the thing, yeah.
Okay, okay, okay. Yeah, I'll share the screen. So, as Nadisha mentioned, like he mentioned, two main types of algorithms, right? Greedy algorithms, and the second one was divide and conquer. So, I'll be looking at a third type of algorithms, which is called dynamic programming. So this might be kind of like complicated for some people, but dynamic programming is actually kind of like divide and conquer. I'll show you with an example how it works. But here in the image, it says dynamic programming is just recursion with cache. So I hope you guys know what recursion is, as Nadisha mentioned in his slides as well. Recursion is calling it at the same function from the function itself, right? So if we introduce some kind of cache or some kind of storing the previous value into that recursion, that's kind of like dynamic programming. So dynamic programming is basically in divide and conquer, we divided the problem into smaller subproblems and solved them recursively. And in dynamic programming, what we do is we divide the problem into smaller subparts, and we basically remember what the value was before basically going to the conquer part, the combine part. So I I am not planning to do a big a long presentation on dynamic programming, but yeah, let's move on to the session. So when we talk about dynamic programming, there are a few things you should know. So same as like this is another type of algorithm. Like there are greedy algorithms, divide and conquer, dynamic programming, and then there are obviously more types of algorithms. But this dynamic programming algorithms are more suited for optimization problems. Basically, problems that require us maximizing something or minimizing something. Basically, if you remember that knapsack problem, there we had to maximize the profit, right? So there we use a greedy approach because it was a fractional knapsack problem. But in the 0 1 knapsack problem, if we want to do that, for example, if the thief was trying to steal TVs and radios, he can't cut them, no. So he will have to either take it or leave it. In those kind of that kind of solution, the greedy approach won't work. So you can actually try and think why, because now you understand the greedy approach. If you think, you will understand, okay, we can't apply the greedy approach for those kind of problems. And in those kind of situations, what we can apply is the dynamic programming one. So, so that's why kind of like most of the optimization problems, they are solvable using dynamic programming. And the problem should be able to like divide into subproblems, right? So similar to divide and conquer, where you need to have the ability. The problem should be dividable into subproblems. And in this dynamic programming one as well, there the problem should be divisible into subproblem as well. And I'll come into the difference between divide and conquer and this. So this is also kind of like that. The optimal solution for these subproblems lead to the solution of the original. So now we have subproblems, and when we solve the subproblems, the result should lead into the solution for the original problem. So this is also kind of like divide and conquer. So you should be able to divide, and when you conquer the divided parts, you should be able to somehow combine them into conquering the original subproblem. And now this is the part that this differs from divide and conquer. So subproblems should share small subproblems, and a solution for a particular subproblem is computed only once. So what this means is, in divide and conquer, the problem was divisible, and then you conquer them and combine. But for some reason, if the divided parts they have some kind of the subproblems are kind of like the same. So if you can share one answer with the other, then you can apply dynamic programming instead of divide and conquer. So I'll draw a sketch and explain. So basically, in dynamic in divide and conquer, what we do is we have a larger input, right? And we divide into two small inputs, and we recursively apply divide and conquer to basically solve this. Now these are solved, and then you combine them. So this is what you do in divide and conquer. And in dynamic programming, what we do is imagine that you had a problem and you divide it into parts, and obviously these need to be divided into some smaller parts likewise. And then the difference between dynamic programming and divide and conquer is that somehow the smaller parts, smaller subproblems, they are the same. I'll show with an example later. So basically, the subproblems they overlap. So you don't have to, if you compute the result of this one, you don't have to compute this one as well, because you know the answer for this, because these two instances are the same. So if I go into the slides again, so I hope you remember the Fibonacci sequence, which was explained earlier. So Fibonacci sequence is the is a sequence where every like every element is the sum of the previous two. So for example, this first two items are always 0 or 1 or whatever, and the third element it's the result of the addition of previous two. So 0 plus 1 is 1. Thus 2 comes from 1 plus 1. 3 comes from 1 plus 2. 5 comes from 2 plus 3. Likewise, 21 comes from 8 plus 30. So the problem is if you give the n. So n we have to give what is the nth term in this sequence. So for example, if you give 3, so we assume this is 0 index, right? So this one is n equals 0, this one is n equals 1, 2, 3. So third term is 2. And the sixth term is 1, 2, 3, 4, 5, 6. Sorry, start from 0. So 0, 1, 2, 3, 4, 5, 6. So it's 8. So Fibonacci is this sequence. So I'll show you how, I'll actually draw and show that sequence. So the sequence is 0, 1. The third one is 0 plus 1, 1. 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. And so on and so forth. And the function, we can actually define the function as because I think you are familiar with the mathematical notation, right? So Fn we can define as when n equals to 0, the result is 0. When n equals to 1, the result is 1. Otherwise, n is the sum of previous two terms. So Fn minus 1 plus Fn minus 2. So this is the previous term. This is the term before that. So this is actually the mathematical function of Fibonacci sequence. So let's try to like code it, right? So here I have shown a sample question which has the so it asks us to calculate the Fibonacci sequence, and the there are several test cases, and for each test case we have to give the nth term. For example, there are 5 test cases: 1, 0, 1, 3, 5, 7. The zeroth Fibonacci number is 0. First Fibonacci number is 2. Third one is 5, and seventh one is 30. So let's try to code it, right? So we know this is the function, right? So what we can do is we can actually, I'll use Python 3, but you can use Java or whatever. It doesn't matter. So I'll actually first loop for n. So because there are like test cases, right? Several test cases. So we use a loop to iterate in each test case. So for in so likewise we can iterate in each test case, and for each test case I'll input the number, right? And now I have to print the Fibonacci number, right? And then we have to write the function. So how the function is, I'll basically write this. So I have written the function like this. So when n equals 0, it's 0. When n equals 1, it is 1. Otherwise, it's this. So I'll write if n equals 0, return 0. Uh, if n equals 1, return 1. Otherwise, return n minus 1 plus n minus 2. So this is the most, this is not dynamic programming, right? So I am just finding the solution, but writing the solution to the question asked. It's just the most basic question. So I'm just using simple recursion. And I actually want to show you how we can improve the solution using dynamic programming later. So I'm just writing the sample code for the base case, right? It's just the most simple implementation. So let's actually test it to see if there are like any errors first. Yeah, we can see that the sample test cases are running. So basically, it means that okay, our code is working. The code is correct. But what about the time complexity? So in the yesterday session I actually explained that yes, your question, the answer might be correct, but sometimes correctness is not the only thing they are checking. So sometimes they actually check for whether your code is fast enough, right? So I'll actually submit the code and show you. So if you submit that solution, you can see, you will see, let's see. Mm, Still cute. Yeah, you can see two test cases they are passing, but other test cases are terminated due to timeout. So basically meaning that our code was actually not fast enough. It was actually slow. So how can we improve this code, right? So this is where a place we can use dynamic programming. So basically, if you can, I'll draw a diagram and show you. But I hope up to this point you understood, right? So this is the most basic implementation of Fibonacci sequence, and it's basically printing the nth term. And as you can see, it runs correctly because for the sample test case it works, but it seems like for larger inputs it's failing. So how can we improve this? So there, for example, let's draw a diagram and see what the algorithm is doing, right? So, sorry. Yeah. So let's see. So let's take f of 6. No, if let's take f of 5. So to calculate the fifth term, what the algorithm is doing is basically adding the previous two terms, right? So it is adding f of 4 and f of 3. And to find f of 4, it needs to again find the result of f of 3 plus f of 2. And to find the result of f of 3, it needs to find f of 2 plus f of 1. And to find f of 2, it needs f of 0, f of 1, and f of 0. And it knows the result of f of 1 because f of 1 is 1. Here we have defined. So f of 1 is 1. And f of 0 is 0. So we know those two values. So f of 2 is the addition of these two, 1. And f of 1 is, we know it is 1. So f of 3 is 2, addition of these two. And then there is f of 2. We don't know f of 2, so we need to again find f of 1 plus f of 0. So f of 1 is 1, this is 0, so f of 2 is 1, and f of 4 is 3. And there we have f of 3. So f of 3 is f of 2 plus f of 1. F of 2 is f of 1 plus f of 0. And f of 1 is 1, f of 0 is 0, so this is 1. F of 1 is again 1, and f of 3 is 2. So we get f of 5 as 5. Okay. So if you see this diagram, you will see that the sum of the parts we calculated again and again. Like for example, I'll show. So for example, if you see f of, for example, f of 3, let's say f of 3. So you calculated f of 3 here, which is 2. And you calculated this value again here. So because this is actually, you can see the problem is decomposing into small sub problems, right? So we had to calculate the fifth term. So we calculate using the previous two, which are small. And then to find the f of 4, we need previous two. So the problem is composable into smaller subproblems. And you can see some subproblems are reoccurring. So f of 3, you can see here and in those in these two places. And f of 2, you can see here, here, and here. And if, for example, we had f of 6, right? So if for f of 6, you will need f of 5 and f of 4. And you need to find f of 4, you have to have another set of like a diagram going from f of 3 plus 2, and 3 becomes from 2 plus 1, and likewise. So when the number becomes large, the number becomes high from 5 to 6, this whole part adds. So from when we go to f of 7, it's a whole another part. So basically, with the number, our diagram, the computation diagram, it becomes larger and larger, and because of that reason, for large numbers, it probably becomes slow. So how can we improve it? So as I mentioned before, you can like, it's not exactly correct, but you can think of the dynamic programming as recursion with memorization. So recursion, but with kind of like a cache. So what we do in recursion, in dynamic programming, is we basically remember the value. So basically, let's say, for example, if we remembered, okay, f of 2 is 1. So if we won't calculate this one because we already know f of 2 because we calculated it here. So f of 2 we don't calculate here. And we find f of 2 here as well, so we don't calculate it here as well. And we find f of t here. So because we know f of t, we won't calculate f of t again. So we won't calculate this. So you can see now, a lot of the tree was reduced, right? So now it's like a linear one. So you can see there is a node here, and then again dividing always into two parts, and the right path is always like reduce, like it's not continuing. So this graph is actually much small. So if we remember the result, we can actually improve. So I'll show you how we can do this in code, right? So uh, what I always remember what I said before. It's like recursion with cache. So I'll have a cache or a simple like dictionary like object, and without returning, I'll actually store the result in the cache. So I'll store the result, except of returning, store the result in cache, and then uh, and then first of all, if we can find the if we will only do the calculation if the result is not already in the cache. So we will only do the calculation if we haven't already calculated the result before. So if number is not in cache, if the number is not calculated before, then we'll do the calculation and store the result in the cache. And so this one becomes, yeah, this, I'll keep it as it is. And then uh, at the end, I'll return the value from the cache. So this is basically what I'll do. So I'll rerun it again to check if it is correct. Seems okay. And yeah, let's try submitting it. Yeah, you can see it, all the test cases are accepting. So now it's running as expected. So this is one way to write dynamic programming. So you can use a cache. There are the most better approach is something like using a tabular method. You can actually fill a table. I won't go into those, implement those approaches. Actually, you can easily find when you Google dynamic programming, you can see. But I just wanted to show that how it can improve your code, right? So basically, what in its core, what dynamic programming really means is that it's basically solving small subproblems, same as divide and conquer. The only difference being the small subproblems, they are actually overlapping, and because overlapping means they are the same, and because they are the same, they will have the same answer. So we will remember the answer to previous subproblems and we will use them later. That's the basic core of dynamic programming. So I'll yeah, go to presentation again. So in the presentation, I won't be going into more details, but in the presentation slide, I'll share them. Because of the time reasons, I won't be going into the next part. So there is another problem, a much more complex one, a longest common subsequence. So the problem is basically like this. So problem is you have, uh, let's say, you have some subsequences. So you have some subsequences like A, B, C, like this one. So there are two subsequences. You have to find the longest common subsequence. So basically, find, uh, uh, for example, you can see A- AB is here and AB is also here. So AB is a common subsequence and it has the length 2. So the problem is what is the longest subsequence we have. So if you so if you yeah in this instance, so the one I have shown in the slide, wait, in the subsequence one, what it means is that, so if you can skip letters. For example, BC is for example BC is appearing here, and you can see BC and B and C are appearing here as well. So they just have to be in the same order, right? So we find B, C, and in the Y as well, we find B, C, but there's D letter, but we don't care about that. So we should have the same letters in the same order. And what is the maximum length? So for example, this is also valid. For example, if we take A, B, and A, B, and A from here, so it has length of 3. So that is also a subsequence. So the problem is what is the longest instance you can find. So in the slides, you can find the longest one is this one, right? So I won't be going into it's actually explain the same thing I explained for the Fibonacci one, and you can actually go to the slides because I won't be going into details of this one because of the time constraint. Because if I explain it, I think it will take much more time as well. So you can go through it. So basically, always think of dynamic programming as like this. Dynamic programming is something like recursion with cache. You are basically finding the result of subproblems. The only difference being you you remember the results of smaller subproblems and use them to solve the larger one. So actually, that brings us to the end of the presentation. As I said before, I was not planning of doing a longer one. So in this session, actually, Nadeesha actually did two approaches: greedy approach and divide and conquer. Greedy approach is basically uh, at each instance we will be greedy and get the most local optimum solution instead of thinking of the future. We won't be thinking of the future. We will think at the moment and take a decision, and we hope that it will lead into answer, the correct answer. But sometimes it does, sometimes it doesn't. But it is always a faster solution, right? And in divide and conquer, what we do is we divide the problem into smaller subproblems and solve them recursively, and then combine them to get the right answer. In dynamic programming, what we do is we have a subproblem, so we divide the problem into small subproblems, and we actually they because they have overlapping uh, subproblems, we remember the result. We actually solve the result bottom up approach or top down approaches, and kind of try to find the like in least number of operations how to remember the result of smaller subproblems to build up the larger one. So that's what dynamic programming is. So I hope it was clear. So next we come to the end of the session. So as I mentioned before, so in the yesterday's session as well, there are a lot of resources to learn. We will be giving the slides of yesterday's and today sessions as well, and go through them, and also go through these platforms. Workforce is extremely good. These ones are good for practicing. Hacker rank as well. You can find the categorized questions. So, for example, if you go to the algorithm section, you will find questions relating to that. So, go through these platforms and try to solve those problems, and you will get better. And then there are books. The second one, competitive programming handbooks. That one I really recommend. And the other ones are actually good for this. The three and fourth ones are good for competitive programming, and the first one is actually very good for learning the theory behind everything. So yeah, that brings us to the end of the session, and thank you for listening. And if you have any question, feel free to ask.
Guys, if you have any questions, please drop it in the chat. Yes, the recordings are available. We'll share them in your groups. So thank you very much, Mr. Sunera and Mr. Nadeesha, for your informative sessions. They've a huge contribution for those who are interested on coding competition as well as the newbies to get interested on them. So we have a virtual token of appreciation for Mr. Sunera Avinash, CTO at IXD Labs. Thank you very much, dear sir, for sacrificing your valuable time and joining with us yesterday and today. And also, we have another token of appreciation to Mr. Nadeesha Madusanka, Trainee Associate Software Engineer at IXD Labs, for joining with us today and making this event a success. Thank you very much, dear sir.